Greetings, trigonometry students. What I'm going to look at in the third part today is what we call reference angles. And reference angles can be useful in understanding how to find a trig function of any angle in any quadrant. And then next section we get into the unit circle and we'll start looking at unit circle a little bit more. So a reference angle, here's kind of the key things. First of all, a reference angle is always an acute angle. So it's always between 0 and 90 degrees. Reference angles are always positive. And to form a reference angle, you always draw an altitude from the terminal side of the angle to the x-axis. And make sure that you never draw to the y-axis. I see students do that all the time. All right, this diagram will show you this more specifically. I'm representing theta is the standard angle. And then the reference angle is going to be theta prime is what I'm going to use on that. So if you're in quadrant 1, you always drop the terminal side straight down to the x-axis or up to the x-axis. And then that gives you your reference angle right here. So your reference angle here is the same as the original angle. So if you're in quadrant 1, then the reference angle is itself. If you go to quadrant 2, notice on this is my angle theta, which might be something like 120 degrees or something like that. And then again, what you always do is you always draw an altitude to the x-axis at a right angle. That forms what we call a reference triangle, and the angle will be right here. So if you're in, and I'm going to write kind of a little formula for each one of these. If you're in quadrant 1, theta is equal to the reference angle. If you're in quadrant 2, your reference angle theta prime is found by doing halfway around the circle 180 degrees minus the angle that you're given. So if this was, 120 degrees, your reference angle would be 60 degrees. Those would add up to 180 or halfway around the circle. Okay, if you're in quadrant 3, this would be your angle theta. And then again, same idea. You go straight up to the x-axis at a right angle. And then this would be your angle theta right there. So what you do here would be something like this. You would do your reference angle theta prime. What you would have to do is you would have to do that angle, you have to do this angle minus 180 degrees in order to get theta prime. So an idea on this would be like if this was say this is a 280, not 280, that's too big. Let's say that you have 250 degrees. Well, then if you do 250 minus 180, you would get your 70-degree reference angle, okay? So you kind of got this. You don't want to memorize these formulas, really. You just want to know what a reference angle is and then be able to reason out how to find one. I don't think of these as formulas, but you could think of them that way. If you are in quadrant 4, you'd be here. That might be something like, say, 300 degrees. Okay, well, then what you need to do on this is you need to do 360 degrees minus the given angle, and then that will give you your reference angle. So, for example, in this case, you would have 360 degrees minus 300 degrees would give you a 60-degree reference angle. So your reference angles will always be acute angles between 0 and 90. And reference angles are always positive, and they're always formed when you draw the terminal side to the x-axis. That's the key. So what we'll do here is kind of begin to just look at some examples where we find some reference angles, okay? So what I'm going to do on all of these problems is we're going to draw the angle just kind of to get a good understanding. When we're drawing an angle in standard position, we always start by just highlighting the x-axis, okay? 80 degrees would be in quadrant 1. So I'm going to go counterclockwise. I'm not going to draw it perfectly accurate, but accurate enough. Okay, so that would be your angle theta. So theta would be 80 degrees that you're given. Well, the reference angle remember, you're always forming a reference triangle, so this reference angle is theta prime. And in this case, it's the same thing. So if you're in quadrant 1, then you've already got the reference angle. Okay, so that would be a reference angle of 80 degrees. Okay. All right, let's go to the next one. This one is a quadrant 2 angle. So you'd be going counterclockwise. You would end up in quadrant 2. Okay, and again, what you get is this is your angle theta. That's the 150 degrees. Then you go straight down to the x-axis to form a reference triangle. And then this angle right here is your reference angle theta prime. Okay, so the way you're going to do this is just reason it out. Halfway around the circle is 180 minus the reference angle, not the reference angle, the given angle. That's going to give you a 30-degree reference angle. So see, in this case, you would have a 30, 60, 90 right triangle. Okay, so again, you're getting an acute angle that's positive, and you're always drawn to the x-axis. Okay, next page. Let's do 230 degrees. Okay, 230 degrees will put us in quadrant 3, it looks like. Okay, so you'll be somewhere kind of in quadrant 3, like that. Okay, so again, what you have is your original angle theta is 230 degrees. So your reference angle, again, you draw to the x-axis to form your reference triangle, and theta prime, your reference angle, will be between the x-axis and that angle there. So just reason out what you would do. To get that reference angle, theta prime, you're going to take that angle, 230 degrees, minus 180 degrees, halfway around the circle. That will give you a 50-degree reference angle there. Okay? All right, so every quadrant you do a different arithmetic problem, but it's just good to reason it out. Okay, now you could also be given this in radians, and there's different ways to do this. This is clearly one of those pi over 3. Remember, pi over 3 is 60 degrees. This is clearly one of those families of angles. So you could go ahead and change this to radians if you want to. Pi over 3 is 60, or change it to degrees, I'm sorry. So you'd have 5 times 60, you get 300 degrees. A lot of times if you're dealing with radians, it's just as well to convert it to degrees and then reason it out that way. Okay, so that's what I'm going to choose to do on this. So initial side is the x-axis. So now we're going to be in quadrant 4. So our angle we will draw this way to get in quadrant 4. Okay, and again, this would be the original angle theta, 300 degrees. Okay, draw to the x-axis to form your reference triangle. Theta prime is your reference angle, so we have to figure that out. So the way we would do this is we would do all the way around the circle, 360 degrees, less the 300 would give us a leftover reference angle of 60 degrees. Okay, now 60 degrees is the same thing as pi over 3 radians. So we probably ought to go ahead and give that answer in radian mode since the original problem was in radians. Okay, you could also do this problem alternatively this way. If you know that this is in quadrant 4, then you could do 2 pi, which is 360, minus 5 pi over 3, like that. You could put that over 1. You could introduce a common denominator of 3, and then notice you would get 6 pi over 3, which is 2 pi, minus 5 pi over 3 to get that pi over 3. It's up to you how you do that. I think most students probably prefer to just change that to degrees so that you clearly understand what quadrant it's in. Eventually, you'll get pretty clear on that. One thing that I think is kind of good for things we'll look at in the future is you can count by pi over 3. I mean, it's 60-degree increments, so that's pi over 3. Another 60 degrees puts you over there. That would be 2 pi over 3. Okay, and if you're just kind of going 60, 120, 180, then you get to 3 pi over 3. And of course, 3 pi over 3 is 3. Then you end up with another 60 degrees. You end up with 4 pi over 3. And then finally, you end up at 5 pi over 3. Okay? And when we start getting comfortable with the unit circle, you'll get those angles down a little bit better at that stage. Okay, next thing we want to do, now this one we need to find a coterminal angle. So before we even figure this out, we need to get the smallest positive coterminal angle. So 360 degrees is 1 revolution, 720 degrees is 2 revolutions. So what we'll do is we'll just subtract 720 from this, and that will give us a coterminal angle that we can figure out a reference angle for. So really we just need to focus on 175 degrees. I'm not going to even bother drawing the original angle. I'm just going to draw 175 degrees. So 175 degrees would put you in quadrant 2. This one's easy enough to do in your head. So you're over here somewhere. And again, this is your that is actually your coterminal angle, 175 degrees. And then again, what you're going to do is draw straight down to the x-axis to form your triangle. So theta prime would be 5 degrees. So you would be doing 180 degrees, halfway around the circle, less the 175 to get that reference angle of 5 degrees. So that's how you would put that together. Okay, one other issue on this. We'll kind of look at this one. We're going to just convert this to degrees. So again, you really have 7 times pi over 3. Pi over 3 is 60. You could also just replace pi with 180. I just happen to see that pi over 3 is 60, and it's worth seeing that. So I end up getting negative 420 degrees. So I really need to find a positive coterminal angle. So if I add 360, if I add 360 to it, I'm still going to have a negative angle, but I'll just do this in 2 steps. Negative 420 plus 360 is negative 60. So you're in that family of angles. And then if we do negative 60 degrees plus 360 again, then we're going to get 300 degrees. And I think in a previous example, we already did 300 degrees. So this will put you in quadrant 4. There's your initial side. And here is your terminal ray. And again, I'm not bothering with graphing the negative 420 degree angle. So you've got theta is equal to 300. Okay, that's the coterminal angle. And then we need to find the reference angle. So we go straight up to the x-axis. This would be theta prime. In that case, it'd be 60 degrees. You can do that in your head. You're just doing 360 degrees minus the 300 is going to give you a reference angle that's 60 degrees. Okay, so that kind of gives you a little bit of everything. We probably also want to go ahead and just write that this way. And again, one thing on that is you got to remember that a reference angle is always positive. It's always between 0 and 90. So you're never going to name this as a negative 60 degree angle. It's got to be positive. So you want to make sure that you always remember when you're dealing with reference angles, these things. It's an acute angle, it's positive, and you draw to the x-axis to get that reference angle. If you remember those 3 things, then you can reason out what the value of the reference angle is pretty easily. Okay, so what I'll have you do is we're going to go to the next page, and I'll have you pause the video and work out, draw the angle and find the reference angle for these 4 cases. On number 3, you're in radians, so you want to provide a radian answer. Okay, I'll go ahead and pause. Okay, so if you want to go ahead and check your answers, what you got on the first one is you have a quadrant 4 angle. So you do 360 minus 290 to get 70 degrees. And then the next one, I went ahead and found a positive coterminal angle by adding 360 to get 200. 200 puts you in quadrant 3. Okay, so to find the reference angle, you would do 200 minus 180 to get 20 degrees. And then number 3, I went ahead and converted it to radians to get 155 degrees, which puts you in quadrant 2. And then again, we would do 180 minus 155 to get a 25-degree reference angle. Then you can see I converted that back to radians to get 5 pi over 36. Okay, and the last one, I went ahead and found a positive coterminal angle by subtracting 720. 190 tells me that I'm in quadrant 3, so I should have just done 190 minus 180 to get a 10-degree reference angle. Okay, all right, so that's what you should have got on that. It's pretty simple to do that, just knowledge of arithmetic and what quadrant you're in, and you're always working with either 180 or 360 when you're figuring out a reference angle. Okay, now what we can do is down at the bottom, we can use reference angles and the special triangles we learned to find the values of trig functions. So we're going to do that in this section, and then in 6.6 we'll transition out of this a little bit and more into the unit circle. So one of the reasons you learn about reference angles is this, and I think it might be at this stage worth showing you something on this. Just kind of backing up on this previous problem and showing you something on the calculator, because this is why reference angles are kind of important. So like if you look at this problem number 1, and let me make sure that I am in degree mode on this. Yeah, so let me put myself in degree mode. Okay, so if I just picked a trig function, I'm just going to use the sine on all these. So the sine of 290 degrees would give you some decimal value. But what we want to do is compare that to what happens when you do the reference angle. So if I do sine of 290, I get that. But if I do the sine of 70, I'm going to get the same thing, but I'm not going to get a negative number. So you'll get a negative for a trig function depending on what quadrant you're in. But the point I'm wanting to make is if you do a trig function of the original angle and the trig function of the reference angle, they should always have the same absolute value, really. They should have the same value, but one could be negative and one could be positive. Same thing would happen on number 2. This time I'll do a cosine. It doesn't matter. I'll do cosine of negative 160, and then I'll do the cosine of the reference angle 20, and see what we get. Okay, so we get the same thing with an opposite sign. And that'll work the same way regardless of which trig function you're working on. So that's what's important about reference angles, is they can be used along with our special triangles to find the value of trig functions. Okay, so this one, let's start with a 330-degree angle. So we'll go ahead and just sketch this. You know that you're in quadrant 4. And draw that real accurate. Let me do a little bit better job of that. So it'll be, I guess, more like that. Okay, so we're going to find our reference angle by going straight up to the x-axis at a right angle. And again, what we would do is we would do 360 degrees minus the 330 degrees to get a reference angle of 30 degrees. I didn't draw that very accurately. Let me go back and redraw that. I don't know what I was thinking. Okay, just so it's a little more accurate. So let's draw that like that. That reference angle is now 30 degrees. And then notice that you have a 30-60 right triangle. And what we learned is it goes like this. The ratios of the sides are as easy as 1, 2 square root of 3. So the 1 goes opposite the smallest angle. The square root of 3 is 1.7, so it will go in the middle. And then the 2 is the biggest, so that's the hypotenuse. Now, one thing you have to be kind of cautious about this is, this 1 is actually could be thought of as a negative 1 because you're going down on that y-axis to get to that point. You actually have a point, which is square root of 3 comma negative 1. You're going over square root of 3 and down 1. Okay, so what you could do is you could just put a negative there. Of course, that x is positive and r is always positive. Now you can use your definitions to figure this out. So the sine is y over r, or you could even think of its opposite over hypotenuse if you prefer. which would be negative 1 over 2. So the sine would be negative 1/2. Okay, we know the cosecant's the reciprocal, so that would be negative 2. Okay, the cosine, its definition is x over r, or if you prefer, it's adjacent over hypotenuse. So if you're looking at the 30-degree angle, adjacent is square root of 3, hypotenuse is 2. So this would be square root of 3 over 2, like that. Okay, the secant would be the reciprocal, so it would be 2 over square root of 3. Don't need to worry about rationalizing denominator necessarily. Okay, this one, I think when I typed this out, I intended this to be the tangent, and this the cotangent, I believe. Okay, so what we would do on this is the tangent was y over x, or opposite over adjacent. So let's just do it that way. Opposite's negative 1, adjacent is square root of 3. So you'd end up with negative 1 over square root of 3. Cotangent is the reciprocal of the tangent, so that would just be negative square root of 3. So once you get your reference triangle, if your reference angle is either a 30, a 60, or a 45, then you can pretty easily figure out the value of the trig functions, okay? Okay, so this one, again, you could change this to degrees if you chose to. I look at this kind of like this. I look at this as 5 times pi over 4. Pi over 4 is 45 degrees. Okay, so that would be 5 times 45. And I'm going to go ahead and just convert that to degrees so we can clearly know what quadrant we're in and everything. So that is a 225-degree angle. And when we draw our angle, we just need to move over into quadrant 3 right here. So somewhere in there, it would actually be right in there. And then we'll make our reference triangle here. Okay, so that reference angle is going to be found by doing 225 minus 180 to give you a 45-degree reference angle. So what you get then is you get a 45-45 right triangle. And then we can put the sides on that. So the sides are 1, 1, root 2 on this angle. So you'd have 1, 1, and then the hypotenuse is square root of 2. Square root of 2 is 1.4. But we have to be careful about this. This really represents an x value. So x can be thought of as negative 1. And then this represents a y value. So we need to represent that by a negative number also. And then r is always a positive number. So we can now go through and do our ratios just by either doing our x over r definitions. Technically what we have is we have this point negative 1, negative 1. Okay, so let's just do the right triangle definitions. The sine's opposite over hypotenuse. So again, you look at your reference angle, the opposite's negative 1, the hypotenuse is square root of 2. Okay, cosecant is the reciprocal, so we got that. The cosine is adjacent over hypotenuse, so adjacent 45 would be negative 1, hypotenuse would be root 2 again. So you just get the same answer on these two problems then. Okay, so that would just give you that value. When you do this, you have to be careful about the negatives. That's real important depending on which quadrant you're in. Okay, the next one's a tangent. So tangent's opposite over adjacent. So opposite 45 would be the negative 1. Adjacent would be another negative 1. So we just get negative 1 over negative 1. So that's positive 1. And then the cotangent is adjacent over opposite. So you would get the same answer. It's just the reciprocal. Okay, so see, you can use reference triangles and reference angles to find the exact values of these trig functions. Okay, all right, so I think what I'll have you do to finish up our video is just do this problem on the next page. So if you want to pause and work this out, you may, okay, and then just resume when you're ready to check. Okay, so if you want to check your answers, just see if you got these right. The key thing you have to make sure that you got is your reference angle is 60, and that makes this a 30-60 right triangle. and the sides will go -1. And that has to be a -1 because you're moving to the left on that in the negative direction. And then this would be your y value, square root of 3. So you can kind of think of this again as x being -1, y being positive square root of 3, and then r being 2. Then it's just a matter of applying your definitions. I did the right triangle definitions, and then I've got that okay. One thing I want to mention on this, when you're doing your homework, you want to go through this methodology. You can use your calculator to check your answer on these problems anytime you want to. So I'm in degree mode, I believe, so that's good. So if I was just to go through and do sine of 120 degrees, then I'm going to get this decimal value. But that's what this is. If you do the square root of 3, like that, and then if you divide that by 2, you're going to get exactly the same thing. You can do that with any of these trig functions. If you do the cosine of 120, you're going to get -0.5, which is what -1/2 is. So they're all checkable on your calculator. Okay, so that'll wrap that up. Hope you enjoyed the video. Hope you do a good job with your reference angles and reference triangles. Good luck.